Good day everyone. We discussed on our last video about scheduling in terms of SQL Server. We will discuss on non-yielding schedulers on this video. Let's get started. As discussed earlier, we present one thread from SQL Server runnable queue to the Windows CPU, and we know that depending on the yield point that is present on our SQL Server code, this thread that is executing on the CPU will have to yield after or before this quantum based on the yield condition. What if a thread executing on the scheduler, let's consider thread 1 is executing on the scheduler, and what if this thread executing on the scheduler doesn't yield even after 60 seconds? In that case, SQL Server understands that there is an issue with this thread and usually generates a non-yielding scheduler message with a dump file which contains more details about the condition. Since we cannot allow any thread to monopolize the CPU, so what happens is like if a thread is executing more than close to 60 seconds on the scheduler, and if it is not gracefully yielding, then what happens is like SQL Server basically generates a condition that there seems to be a problem, and that problem would be the non-yielding scheduler. So what would be the possible reasons for a non-yielding scheduler? Bug on the SQL code. So the bug refers here that there is no proper yield point defined on that particular code, and due to which this thread doesn't yield. Reason number two, maybe it is an CLR code which can cause this problem, wherein it continuously runs and doesn't yield. There is a possibility spin locks can cause this problem. Spin lock implementation is utilized when the thread is looking for a resource, and if it is used by something else, in that case, spin lock will call an empty while loop, and after certain quantums, it will check again till the resource is available. This implementation, as far as spin lock is concerned, is done when access to a resource is expected at a very, very short time. And this avoids context switches, and this basically kind of takes care of the resource contention and things like that. But spin lock will utilize CPU even though it is basically going to wait. That is, it is going to use some quantum before coming back and checking for the resource. And this can lead to a non-yielding condition in some cases where spin lock runs for a longer time. The next point, the next reason could be like it could be like we can get this non-yielding schedulers if there is a thread starvation condition as far as the CPU is concerned. What if there was a high priority thread that is running on the CPU continuously and not letting SQL Server thread to run on the CPU? In this case also, SQL Server thinks that SQL Server thread, which never got a chance to run, is not yielding, or it is basically like there waiting for its CPU. And what happens? SQL Server basically thinks it to be a non-yielding condition. The next reason would be like, what if the Windows VM where the SQL Server is installed is getting into a situation where the whole VM is getting freezed for, say, some minutes or some seconds. Even in this case, SQL Server thinks that the SQL thread is not yielding depending on the situation. But in reality, the problem seems to be something else. But SQL Server thinks that it could be a problem as far as the SQL thread is concerned, and then non-yielding scheduler situation is kind of called up, and a dump will be generated. SQL Server utilizes schedule monitor that runs every 10 seconds to check for any non-yielding condition on the database server. It creates a non-yielding dump when a particular thread is not yielded even after 60 seconds. If you check the DMV, sys.dm underscore os underscore schedulers, we have a column called yield count. If this value doesn't increment after 60 seconds or say 1 minute, then it is considered that the particular thread has not yielded and the non-yielding scheduler condition is kind of met. SQL Server, as soon as the non-yielding condition is met, it will capture the thread stack as non-yielding call stack, and then captures one more call stack of the thread as current call stack when the dump file is created. Just to repeat the things, it basically captures an initial stack called non-yielding call stack, and then while writing or creating the dump file, it creates another stack within the dump file called current call stack. There will be some seconds difference between these two call stacks capture. So let's consider if both the non-yielding call stack and the current call stack are one and the same, then it proves that it is a definite non-yielding condition, as the stack did not change at all. The reason could be anything, maybe in spin lock or VM freeze, but at least we will know like it seems to be a definite non-yielding scheduler condition. But on the other hand, if the non-yielding call stack and the current call stack are somewhat different, then that means that the thread has basically moved. That is, it might have yielded or it has basically moved, and that's the reason we are seeing a different call stack for the current call stack when compared to your non-yielding call stack. In this case, this doesn't seem like a non-yielding condition, but the reason why the thread spent close to 60 seconds on the scheduler should definitely be checked further. We can check the kernel time and user time spent by this thread by analyzing this thread in the sense like the current thread that is executing on the scheduler for say like 60 seconds or so, and that is when we got this non-yielding scheduler condition. Um, we can analyze that particular thread, and we can check for the kernel time and user time spent for that particular thread using the WinDBG on the dub file. If the kernel time is more than the user time, then it implies that the thread has spent more time on the kernel mode, and the problem could be mostly on the operating system. On the other hand, if the user time is more, then that means the code seems to have some issue. The code, that is the underlying code that particular thread is executing, can be an issue. Could be a problem with the SQL server or that particular process that is running. But if the kernel and user time is kind of both at zero, that is like no time is spent as far as kernel and user time is concerned by that thread, then that means SQL Server seems fine, but it never got any CPU at all. It's a kind of an thread starvation situation where SQL Server thread never got chance to run on the CPU. That's it for this video. We will speak about deadlock schedulers on my next video. Thanks for watching. Have a great day. Bye. Jai Hind.